right, so I'm going to show you how to graph secant functions by using your cosine function. So let's say they ask you to graph y equals 2 secant x plus pi. Instead, you're going to graph y equals 2 times cosine x plus pi. So remember that I already did a video on cosine, so I'm just using that same function itself, and I'm using the same x and y points that we got and also the same wave. It's already graphed. So if I know how to graph cosine, which please review that cosine graphing video if you haven't already done so, then I already know how to graph secant. So just kind of the shortcut first. When you have a cosine graph, you're graphing one period, which means one wave, one cycle. After that, everything will repeat, meaning if this goes down to -2 and then back up to +2, then the rest of the wave will continue doing the same pattern at the same interval. So notice that the x intervals are at pi/2. So pi/2 plus pi/2 is pi/2 plus pi gives me 3 pi/2, and then from here 2 pi, and on and on and on. Same thing here. Once it goes down and goes back up, it repeats the same cycle. It will go back down to -2 and then back up to +2. So once I have a cosine wave, I like to refer to secant as the hills and valleys of that. So anywhere where you have the maximum of your cosine graph, that's actually where the hills are for the secant graph. And anywhere you have the minimum point for your cosine graph, that's what I like to call the valleys. So notice that the minimum is down at 0, -2. So there will be a valley. What about the intercepts? What about the points in between? Because there's a max, a min, and then there's a point in between, which are the intercepts. Well, from here, those would be my vertical asymptotes. So just like in the question for secant, asking you where the vertical asymptotes are, well, in this case, they're at -pi/2 and at pi/2. So I'm going to give you kind of a better visual of what this graph looks like. So without the cosine wave, this is what the secant graph would look like. And I'm kind of erasing some of the secant graph while I'm at it, so I'll clean that up. So this is pretty much what the secant graph will look like. So how does that come about? Well, let's just say I actually did make an XY table, and you use the same thing. You find A, you find B, period, C, you do the start and stop. So the X values will still be the same from cosine. So we're going to keep those same cosine values. And this is just the proof. So if you just want to do the hills and valleys, you can just keep it moving from there. But if you actually want to see the proof, let's see how this happens. Well, I'm going to plug in -pi. So y equals 2 times secant of -pi plus pi. Well, -pi plus pi is 0. And what is the secant of 0? Well, we have to find the cosine of 0 first on our unit circle. If you go to 0, the cosine value there is 1, and the reciprocal of 1 is 1. So the secant of 0 is 1. 1 times 2 does give me 2. So if you look at -pi, I do have a point at 2. It goes upwards. And if I plug in -pi/2, so y equals 2 times secant -pi/2 plus pi. -pi/2 plus pi would give me pi/2. So again, in order to find the secant of pi/2, I need to find the cosine of pi/2. So go to pi/2, which is at 90 degrees. The cosine value there is 0. Now, the reciprocal of 0 and the reciprocal of cosine, which is secant, the reciprocal of 0 is undefined. So since I'm multiplying 2 times undefined, it's still undefined. So remember, the reciprocal of 0 is undefined. When I have an undefined value, that translates to an asymptote, which is what I have here at pi/2, or -pi/2. And you can continue on and on. So if I were to plug in y equals 2 times secant of 0 plus pi, because the next x value is 0, that would give me pi. The cosine of pi is -1. Well, remember, fraction form of -1 is -1/1. So if I flip that with the reciprocal, it will still be -1. And -1 times 2 is -2. So if you notice, all the values are already what I worked out. So here again at pi over 2, if you plug it in, you'll again get undefined, and undefined graphically means an asymptote. And then at pi, you'll have a value at 2 after plugging it in, and notice that the value is already at 2 and it goes upwards. So this is one period of your secant graph. Hope this helps.